There we go. There we go. All right, so an archer standing on a cliff 48 meters above the level field below, shoots an arrow. At an angle of 30 degrees. At an angle of 30 degrees. Above horizontal. Alright? Above horizontal. With a speed of 80 meters per second. Question is, how far from the base will the arrow land? All right? Now remember, we're going to go through our problem solving procedure as we always do. Right? So, an archer standing on a cliff 48 meters above the level field below shoots an arrow at an angle of 30 degrees above horizontal with a speed of 80 meters per second. How far from the base of the cliff will the arrow land? So, what's the problem? What are we looking for? The distance. You're looking for distance. And we're looking for horizontal distance, right? So we have to be very specific. Horizontal distance. Horizontal distance. And I use that because I want to remind you of the difference between horizontal and vertical, because we get those confused sometimes, especially if we don't use them often. So horizontal means X, side to side. All right? So 2 is time scale. We'll skip that. That's fine. We don't need it. Let's just write time scale. 3 is the givens, right? What are the givens here? Huh? What is 48 meters? What is 48 meters? 48 meters is a speed? Speed, I mean, 48 meters is a distance, right? And it's a what? Vertical distance. And we also have what else? We got the theta, which is the angle he threw it off, or she threw it off at, or shot the arrow at.
Gravity.
Of course, we got gravity, 9.8 meters per second squared, because we're undergoing projectile motion. Anytime an object undergoes projectile motion, it is affected by gravity. And what else do we have? Huh?
Wait, no.
Nope, that's just the regular velocity, the regular speed, right? V, right? That's the magnitude, right? V. All right. So now we at step 4, right? And what is step 4? Let's draw a diagram. Sure. Right? So we're going to draw our cliff here. Right? And our cliff, a little jagged there, comes down here. Boom. Right? And here's our person, the stick man. There's our person shooting the arrow. Right? So he shoots it. Boom. And of course it takes a projectile motion like that, right? And so, right, what we're interested in is what? This distance right here, right? This is the distance X. This distance from right here, right, to right here is what? Y. Right? And we know that the initial speed or velocity of the arrow, which is a vector, right, was what? 80 meters per second. And it was at what? 30 degrees. Right? And so now 5, we're talking about equation, right? So we're going to use the free fall equation, right? To start with, right? So free fall, right? And that is what? Y equals Y naught plus V0 in the Y times T plus, in this case, it'll be, oh yeah, let's do minus 1/2 GT squared, right? And then once we find, so from here, from free fall equation, we're going to be able to solve for time. Once we get time, we plug time back into what? Distance equation, we get what? Speed times time gives us what? Distance. And that's what we're looking for, right? So let's start with the free fall. So Y is what? Right. Now, if we take this to be 0, then Y is not 48, but what? If this is 0, it's not 48, but what? It goes below 0, so it's a negative 48. Right? So that's what we're going to put right here. Right? So on last time, I went and looked at it last night, and I missed that step. So this should be negative. And that's an important point of this problem, right? Because most projectiles do what? You throw them from the ground, and they end up back where? On the ground. So your Y goes from what? 0 back to 0. In this case,
you throw it from the ground, but you already elevated, so
it's gonna go below from where you threw it.
Right.
So that's gonna change your math up. That's physics right there. So negative 48, we start Y naught. This is Y naught up here. We call that what? 0. So that means this is what? negative 48 meters. Negative 48 meters. All right? Plus, and remember we got to do our vector, right? How do we do our vector? Somebody help me. I need help. I need my V. This is V, right? V is 80, right? So what is V X and V Y? This is theta, right? Somebody help me out. Hurry up. Taking too long. Okay? That's fine. So Vx. Okay, so then when I rearrange that, it's going to be what?
80 sine, 80 cosine.
80 times cosine. Cosine of 30. Then we got what? Vy is what?
69.2. Which
It'd be 80 sine.
80 sine 30. All right, so we got that. So that's VOY. So VOY is this one, 80 sine 30 times t, right? Minus 1/2 9.8 squared, times t squared. You following that? Now we got what? Negative 48 equals what? 0 plus what's 80 sine 30? Sine 30 is 1/2, right? So 40t. And then half of 9.8 is what? 4.9? 4.9 t squared. Right? So now I'm going to write this from, because here it's written like backwards, right? We normally write from what? Left to right. So I'm going to start this one, put this one out first, and end up with that. Right? Not just yet, but we're going to have to, right? So negative 4.9 t squared plus what? 40t plus 0 equals negative 48, right? I ain't changed nothing. I just changed the, flipped the sign so it can look normal to us. See it? So now I'm going to bring this back over, right? See that? Bring this over, so now I'm going to have what? Negative 4.9 t squared plus 40t plus what? 48. Right? That equals what? 0. Now I'm going to multiply both sides by negative 1. And when I multiply both sides by negative 1, that changes that to what? Positive 4.9 t squared minus 4t minus 48 equals 0. Now that looks just like this, right? Ax squared plus bx plus c equals 0. That's the standard form for the quadratic equation. So we took our mechanics equation, plugged in our numbers from our givens, and rearranged things to get something that looked like the standard form. So now once we do that, then we can do what? Solve. Because now we know what? A is equal to what? Somebody tell me what A is equal to? 4.9. B is equal to negative 40. And C is equal to what? Negative 48. Now if I plug them in, I should get my time. I'm probably going to get 2 answers, right? I'm gonna get a time coming up and then a time coming back. Or I'm gonna get a time, I'm gonna get this time, this is gonna be my first time right here. And then my second time is gonna be this time below.
It's gonna speed up.
Well, it's accelerating because it's gravity. Yeah, gravity is gonna speed it up. But my point is that time, right? So when you do the quadratic, so somebody, y'all not done. Y'all gotta solve the quadratic for me and tell me what the time is. Okay? So you gotta put it into this equation, right? X is equal to minus b plus or minus square root, excuse me, of 4ac over 2a. And you should come up with 2 times. Because I got a plus and minus there, right?
Isn't it, the square root of? B
Oh,
squared?
yeah. Sorry. B squared minus 4ac. Yeah, I move, my hand moves, or my mind moves faster than my hand sometimes. All right? So it took me years and years to master this kind of stuff, y'all. Years. So you have to practice this. And let's see what time, what's the correct time we should get. Well, I guess you're gonna get a pretty large number. I guess because a cliff 48 meters tall is pretty high, I guess. And then once you get the time, then you take that back into plug that here, right? And you can calculate what? The distance that it traveled from the base.
So will we get 2 numbers or just 1?
Yes, that's what I was telling you. 2, you should get 2. One of them should be negative. So you're only gonna take the positive. Because the negative number is imaginary, right? Please somebody get it right the first time. Y'all get it right the first time, we're gonna leave early today. Anybody got a number yet? What number you got?
I didn't get a negative number either.
I got 5.29 and I got 2.87.
Okay. Let's see. You didn't get a negative number either?
I got 2 positive.
What 2 positive numbers you got?
I got 6.70 and 1.46.
Okay, yeah, y'all got PEMDAS problems. That's all. That's PEMDAS. Or the operations. Put them in the calculator, right? I check the constants. We got the constants right. These are all right. Okay? So you should be getting 9.23 seconds and negative 1.06. Yep, we got everything right. 9.23 and negative 1.06. Let me see what you added into the calculator. 40, that's 40, yep. And, yep. And, 9.8, we got it. What was it, right? 9.8. All right, so yeah, you're just not gonna use the calculator, right? That's right. You got. I say break it up. Do this part first. Find that number. Right. Just break it up. Break them up. You know what I'm saying? So you know. Violate anything. That's all the right numbers though. B is 40. Right? B is 40, yeah, negative 40. So out front, you're going to go positive. It's going to go positive because it's a negative B. Yep. A is 4.9. Yep. And C is negative 48. Yes, indeed. So you can't calculate this with your hands now, right? So you're not using the calculator.
Okay, I think I see what I messed up. I subtracted 1600 minus it. It's supposed to be plus. And then, let me see what I get.
You got the 9.23 and negative 1.06. For AC.
Yeah, I get 480.
That's right. If you don't practice these things, folks, that's when you figure that out on test day.
You got, one of the numbers is negative 1.06.
Yep. And the other one is 9.23. So see if you get the other one right. You got that one, you're gonna probably get the other one. Yep. Well, 23, whatever. And so now you take that and you take that 9.23, which is your real time. The negative one is imaginary, so we throw it out. You take the real time and you put it into here, right? And of course, this is VO and the X. So this is gonna be what? 80. So your X is gonna be what? Let's write it up here. See if you get that right. Right? So now X is gonna be equal to VO and the X times T. So it's this, right? VO and the X is what? 80 is it cosine? Yeah. Cosine 30 times 9.23 seconds. And that should equal to like 600 or something meters. Oh no, one, yeah.
600.
Yeah, 639 meters. All right. So, Any questions about that? Any questions about that? Alright, so that was quadratic equation. And I think I put some problems on mastering. Well, no, I haven't done it yet because I wanted to get through quadratic equation first. Okay? So I'm gonna stop here, but I'm gonna add some problems for you on mastering. Okay? So we done for the day. I ain't gonna start no more problems because they all pretty much require majority of the class period at this point. I need to explain them properly. All right, so pay attention, and we got the roll started, right? Everybody sign the roll. As I mentioned to my other class, your midterm grade was based upon maximum. That's it. All right. But when we get to the end, I'm going to consider all components, your attendance, everything. Okay. So don't think that attendance and all that kind of stuff can't hurt you. All right. So make sure you finish strong, and you won't have to see me again. All right? But yeah, so pay attention for mastering, and we gonna, like I said, next week, Monday, we in 4, and we getting ready for our next exam on 3 and 4, coming up soon. All right? And I'm gonna grade y'all stuff, and I'll put it on campus. All right, that's it. It's understandable, right? Everything makes
Yeah, I
sense?
just need to work on playing with the calculator, though. Like plugging it in for real. Plugging it in, I should be straight. Don't forget to open it and tell them what you want.
Okay, yeah, send me an email or something.
By the way.
I don't know.